Hello again, still on arithmetic series, and what I want to do is I want to take this series right here, 1 plus 4 plus 7 plus 10 plus 13, and I want to write it in sigma notation. Basically, I want to write it with the I, that weird Greek letter, and just figure it out. Now I should preface, well actually no, I'm not going to do that just yet. I'll show you first and then kind of explain that. So it's really pretty cool. If you want to write it in sigma notation, the first thing you got to do is write that sigma sign. Now, I should say this, I should not just assume, I should clarify on it. Like, if you start on I equals like 5 to 8 or something, and you can transform it, yeah, of course you can transform it. But when I'm writing this, I'm assuming that I'm just starting from the first term. I'm assuming my I is 1. Now, that's what I'm assuming. That's the first value that I'm going to substitute in or plug in. I mean, I know, yeah, if this is a 5, you can go 6, 7, 8, 9. You can go to 9. And then say, oh, you know, I did it differently. No, I'm saying that it starts from 1. So that's a big, you know, like, hey, this is what we're doing. This is our condition that we're working with. Okay. Now, what's really interesting here is if you want to write this in sigma notation, let's see how it goes. There's 1, 2, 3, 4, 5. So it caps out at 5. And how I did that is very simple. I assume that I equals 1, 2, 3, 4, 5. Goes to 5. Now, the most difficult part is figuring out whatever this is here. And there's a way to do that. And the way you do that is, one, you got to make sure it's an arithmetic series. Plus 3, plus 3, plus 3. Okay, it's an arithmetic series. I use the common difference to figure this out. Now, what I do is I put a 3 in front of the I use it as a coefficient in front of the variable. So it's 3i. Now what's really interesting is 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 3 is 15. It doesn't match up. So I gotta say to myself, okay, 3 times 1 is 3, how do I get a 1? Well, okay, 3 times 1 is 3, how do I get a 1? What do I have to do? Subtract 2. Check it out. 3 times 1 is 3, minus 2 is 1. 3 times 2 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 3 times 4 is 12, minus 2 is 10. 3 times 5 is 15, minus 2, 13. Bam! That's how you do it. And I went ahead and I did 1, 2, 3, 4, 5. Okay, story checks out, that works. One last thing I want to preface, because when you do geometric series, this is something that's very difficult for students. If I show this now, though, it'll make more sense. If you look at this problem, this is an example of an arithmetic series. And I know it's an example of an arithmetic series because I'm taking a number and I'm multiplying it by a variable. This, however, is an example of a geometric series. 3 times I would be arithmetic. You know, 1, if I multiply by 1, 2, 3, 4, 5, it's going to always be adding the same number. 3 to the power of I is different though. Like 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9. And I didn't explain it yet, so maybe it's very difficult. 3 to the 3 is 27. What I keep doing is multiplying to get to the same next number. So this is something called geometric, and this is arithmetic. If you're working with arithmetic sequences, you know, make sure it's not a number and then power to the I. That's automatically geometric. Well, yeah, at least in the examples that we use to an extent, because technically you can use recursive formulas too. We haven't even talked about that. But if it's a number times a variable, even 1 times I would be an example of that. That's an example. Yeah, so with that said, I hope you found that helpful. And we'll have to move on to geometric sequences and series. But for right now, have a great day. Goodbye.